We're going to continue our discussion by looking at how to solve non-homogeneous linear equations. We're going to focus on linear equations that have constant coefficients, and we're also going to focus on a method called the method of undetermined coefficients. So let's recall a few things. First of all, let's recall that if we have a solution yc equals c1 y1 of x plus c2 y2 of x, assuming this is the general solution of general solution of, say, let's do ay double prime plus by prime plus cy equals 0. And then let's also assume that yp is the particular solution of, let's now do ay double prime plus by prime plus cy equals g of x, where g of x is not equal to 0. Then the general solution I might as well continue calling it so, of, let's call this, I'm going to call this asterisk, maybe asterisk 1, or just asterisk. The general solution of asterisk is now y equals yc, y of x is equal to yc of x plus yp of x. Okay. So if we have a homogeneous solution, a homogeneous equation, and we have a corresponding non-homogeneous equation that its left-hand side is the same thing as that of the homogeneous solution. Now, assuming yc is a solution, the general solution of the homogeneous equation, and yp is a particular solution of the non-homogeneous equation, then the general solution of the non-homogeneous equation is just yc plus yp. We're going with that. Okay. Let's solve some problems using this knowledge. So let's solve the ODE. Y double prime plus 4y prime minus 2y equals 2x squared minus 3x plus 6. All right, let's do it step by step. I'm going to say that the first step, step 1, is to solve the homogeneous version of the ODE. Which is y double prime plus 4y minus 4y prime minus 2y equals 0. So our characteristic equation, how about let me use a different color for this. Oh no. So our characteristic equation is r squared plus 4r minus 2 equal to 0. If we solve for r, we're going to get negative 4 plus or minus square root of 16, I think 16 minus 4 times 1 times minus 2, I hope I'm right, all over 2. This boils down to be, I think, negative 2. Inside there we have 16 minus 8, 16 plus 8, 24. So this is going to be plus or minus square root of 6. Okay, so that's our roots. So the general solution to the homogeneous equation, let's call it YC. YC is going to be C1 e to the power of negative 2 plus square root of 6x plus C2 e to the power of negative 2 minus square root of 6x. Okay, so that's our first step. Let's look at the second step. The second step now is we're going to look for YP. We don't know what YP is, but we have the left-hand side or the right-hand side of the equation. The right-hand side of the equation is 2x squared minus 3x plus 6. So this is a polynomial, a second-order polynomial. So we can just assume that our YP has that form, right? So what do I mean? We can say let YP be equal to, say, ax squared plus bx plus c. And then we can find these coefficients, all right? So that's where we got the name method of undetermined coefficients. These coefficients are not determined yet, but we can determine them. If this is the case, y prime of p is just 2ax plus b, and yp double prime is going to be just 2a. What do? We go back to our equation and we plug this back into this equation, right? We have this equation. We're going to plug yp into this equation and see what happens. So we have that yp, make it a little larger, that's what I want to do. Yp double prime plus 4yp prime minus 2yp is equal to, so let's save this for now, this part for now. But this is actually going to be equal to yp double prime is 2a plus 4 times yp prime, 4 times 2ax plus b minus 2yp minus 2 times yp, which is ax squared plus bx plus c, right? All this should equal 2x squared minus 3x plus 6, okay? So all we have to do now is look at the left-hand side, collect like terms. All the terms with x squared in them, let's collect them together. All the terms with x squared in them is just 2ax squared, just here, right? Negative 2ax squared. Then let's look for the terms with x. So plus the terms with x, if we look at this part, we have 4ax times 4 times 2ax, so 8ax, and then minus 2bx. All right, so we can write it as 8a minus 2bx, 8a minus 2b, and then we have x. All right, so we've taken care of this, and we've taken care of this. So we're now left with just 2a, right? This 2a right here, and then 4b because of this b right here, plus 4b, and then minus 2c. Okay. All right, so this is the left hand side. This should be equal to 2x squared minus 3x plus 6. Okay, so what are we doing? We're going to compare these coefficients. We're going to compare this to that because they both have x squared. And then we're going to compare this to this because they both have x. And then we're going to compare that to that. All right. So let's get to work. If we, by the way, this is an identity. This is not quite an equation. It's an identity because it's valid for every value of x. So let's use that. The triple strokes is a sign. It's like an equality sign, but it kind of tells us more that it's an identity. It's not an equation. We're not solving for x. All right, so what do we have? We have negative 2a. First of all, negative 2a is equal to 2. This tells us that a is 1, right? So we have one solution for the variables. And then we also have that 8a minus 2b is equal to negative 3, right? 8a minus 2b is equal to negative 3, but a is 1, so it just becomes 8 minus 2b is equal to negative 3. If you solve for b, you get that b is equal to 5 over 2, right? Is that 5 over 2 or negative 5 over 2? Let's see, negative b, and then I think a is negative 1. Yeah, a is negative 1, so this is just going to be negative 8, I think. All right, so b is going to be negative 5 halves. So we found b, we found a, and we found b. So let's now look at the third one. 2a plus 4b minus 2c is equal to 6. This tells us that 2a is negative 1, so we have negative 2. 4b, b is negative 5 halves, so this is just going to be 4 times 5 halves is going to be negative 10, right? And then c, we don't know what c is. We're looking for c actually. So this is 6. So this tells us that c is going to be, let's see. This is negative 2c is equal to, this is 18. So that means that c is equal to negative 9. Okay. So that our yp is, we chose yp to be ax squared plus bx plus c. So yp is now a is -1, so it's negative x squared, and then minus 5 over 2x minus 9. All right. So what have we found? We found that we have a yp, but now let's go back to what we started with. We have a general solution for the homogeneous version. We have a yp for the non-homogeneous. So our general solution for the non-homogeneous now is just going to be, let's call it step 3. Step 3 is very, very short. So step 2, find yp. We found yp. Step 3, just combine them. The general solution of the non-homogeneous equation is y of x equals yc of x plus yp. So which is the same thing as, what's our yc? Yc is this. Okay. That's our yc. And then yp is that. All right, so that's how we solve a problem with the method of undetermined coefficients. Now let's see what else we can do. Let's try another one. Let's try number 2. Let's solve y double prime minus 9y is equal to -10 cosine x. So if you're taking the course with me, you know that we looked at this problem in class. So let's do the step 1. Step 1. Solve the homogeneous version, 9y equals 0. And we actually, in class, we solved this and we got that yc is equal to c1 e to the 3x plus c2 e to the -3x. You can solve it. Step 2 is to find your yp. So our yp, we can say let yp be equal to, now this is interesting. Whenever you have a cosine or a sine, you want your yp to be something like that. So you might want to go a is equal to cosine x. But at the same time, since cosine and sine trade their derivatives, like the derivative of sine is cosine, derivative of cosine is negative sine, so it's quite possible that y could be either of them. It could be sine, it could be cosine. So to be more general, we could also say plus b sine x. That way, if it's just cosine, then b is going to be 0, and if it is just sine, and then a is going to be 0, and it's possible that it's both of them. It's a and b are non-zeros. So that's our yp. Let's do yp prime. Thus yp prime is going to be negative a sine of x plus b cosine of x. And then yp double prime is going to be minus, no, it's going to be just a cosine of x, right? No, what am I doing? Yeah, negative a cosine of x. Yeah, minus b sine of x. Okay, good. Now, what do? We go back to our thing right here, our original equation, and we plug these things in there. Go to this original equation. So this is the right hand side. Put it right here. So y, we're gonna do this for yp. So yp double prime is negative a cosine of x minus b sine of x plus 9 minus 9yp, 9 times a cosine of x plus b sine of x. And all this is equal to negative 10 cosine x. So what is this telling us? This is telling us that we can collect like terms, collect all the cosine terms, the cosine coefficients, sorry, negative a for that part, for here, negative a, and then negative 9a. And that is cosine x. Basically, 10a is cosine x, right? Okay. So, and then we have plus. What do we have? So we've dealt with this too. So we now have minus b, right? Minus 9b sine of x is equal to negative 10 cosine x. Okay. All right. So we have something going on here. We have negative 10a cosine x minus 10b sine x is equal to negative 10 cosine x. So we can now combine coefficients or compare coefficients. What do I mean? So this has to equal negative 10 and this has to equal nothing here, has to equal 0. So we can conclude that negative 10a is equal to negative 10, implying that a is just 1 and b is 0. b is obviously 0 because there's no sine x here. All right, so it's not always this easy. It's not always this this is a coincidence that we have b equal to 0 and a negative 10a is just negative 10. That means a is 1 because we have this right here. That's a coincidence. It doesn't always happen that way. So we now have that our yp is just cosine x. Cosine x, right? Therefore, the general solution of our non-homogeneous equation is y of x, which is yc plus yp. Yc is c1 e to the 3x plus c2 e to the negative 3x, and then yp is just cosine x. Again, this is your yc, and that is your yp. All right. Okay. What else can we do? What else can we do? Okay. Let's look at a third one. Let's solve y triple prime minus 3y y double prime plus 3y prime minus y equals 4e to the x. Okay. So I think let's see. Well, I want you to try that. Think of what it's gonna be, and the next one I want you to try is y double prime. Okay. So I want you to find a particular solution. Just find yp for each of this. Find the particular solution. For each of this, right? A y double prime minus 3y prime minus 4y is equal to 3e to the 2t. Okay. And then B y double prime minus 3y prime minus 4y is equal to 2 sine t. And then let's see, y double prime minus 3y prime minus 4y is equal to 3e to the 2t plus 2 sine t. And then D, I think let's stop there. Yeah. Okay. Find just stop there. All right. Okay. I will see you in class, or I'll see you in the next video. Later.